Hi there, AP Calc students. Now we're going to get into the nitty-gritty of this chapter 6, integration by substitution. And here's where things start to get a bit hairy, but hang in there and I think you'll do okay. You might not understand this totally on this first viewing of this video, but as usual we'll be working on this stuff in class quite a bit. So we use this integration by substitution when our integration is too yucky. Most of the ones we've seen so far we've been able to figure out how to do the integral, but we'll start seeing some of these now that are pretty much impossible just to do by the usual rules of integration. So here's our basic rules, as we can see here for this u substitution. Set the yuckiest part equal to u, and u is just any kind of variable, but that's usually what we use. Then we want to try to find that derivative, du over dx. Then we rewrite the integral with u's in it, and we make sure to cover all the bases. I'll show you what that means. Then we integrate it because now it should be a little bit easier. And lastly, then we substitute back to get my final answer. So here we go with some examples. Let's just see what we can do with these. Alright, so here's our first example here. The sine of 3x plus 5 dx. Now, not always necessary to do a u substitution, but we will in this case just so you can see how this works out. So in this case I'm going to say that u is the yuckiest part here, which will be 3x plus 5. And you might wonder, well, how do you know what to use for u? Most of the time it will be pretty apparent. Sometimes the problems will even tell you what to use, and eventually you'll kind of get the hang of it. Now if that's my u, could you tell me what du over dx is? Well, we just have to find the derivative of this. So it would be just plain 3, right? And then I would like to try to solve this for dx, actually, is what I'd like to be able to do. So I'm going to just rewrite this a little bit. This should probably have been 3 dx is what I would like to do initially. I'm going to erase this right now. Sorry about that. And then, just to kind of match things up a little bit, I'd like to get this dx by itself. So now what I'm going to do is just divide both sides by 3. And so now this is du over 3 equals dx. Now that looked kind of confusing, I know. But now let's see the advantage here. Now I'm just going to make my substitution in my original integral. So I still have that sine, but now notice that instead of saying the sine of 3x plus 5, I'm going to say the sine of u. And then instead of saying that dx, I've solved this for dx, and dx now is going to be du over 3. So that's what I mean by covering all the bases. I mean that you want to try to fill up all this integral notation with your substitution. Now keep in mind another way that I could simplify this a little bit. This 3 here, I can pull that off in front. That was one of those integral rules that we have seen. So then I have 1/3 times the integral of the sine of u du. Now this is something I think I can integrate a little bit easier. Notice nothing happens to the 1/3. What's the integral of sine? Well, we probably remember that it is negative cosine. Again, I'm still using this u notation here. And remember, when I actually do the integral, what do I tack on to the end? Plus c. Now I'm almost done. I just have to resubstitute what I had originally found for u. So in place of that u, I'm going to put 3x plus 5. And I still have my plus c here. And then just to finally clean this up a little bit, I'll call this negative 1/3 cosine of 3x plus 5 plus c. So there's your first u substitution. I kind of botched that up a little bit over there, I think, but we're going to see a couple other examples here coming up next. Alright, look at this bugger. Now this certainly looks quite difficult, that you probably would not want to tackle this just using regular integration, but let's just see what we could do. Remember, we say we like to let this u be the yuckiest thing there, And what would you say is the yuckiest thing? Well, probably that x squared expression. So x squared plus 2x plus 3, that's the yuckiest part. Now I always like to find du over dx. That means the derivative of this with respect to x. And sure enough, that's going to be 2x plus 2. Okay? And then I will, a lot of times, just try to solve this for du. Last time I didn't, but I think this will make more sense here when you see this. So 2x plus 2, I'll put that in parentheses, times dx. Now, what I mean by covering all the bases is this. Notice this 2x plus 2 dx will actually go in place of this and this, won't it? So I'll be able to substitute this du in place of that. And sure enough, here's my u up here. Notice that that's going to be the same as e to the u. So when I rewrite this, notice I can now write this particular integral as e to the u du. Because I had my original e, the u is my more complicated mess, and then I just saw that du is equal to this 2x plus 2 dx. Now I can easily integrate this. Remember when we integrate anything to the e power, it's just the same thing. So my answer becomes e to the u plus c. And then finally I just substitute back. So I put my u in place, back in place of u, and so I get e to the x squared plus 2x plus 3, all of that plus c. And there's my final answer. So this one is certainly tailor-made for this u substitution. One final one we're going to look at, and that is this one right here. This one looks like the worst of the ones that we've seen. I think it probably is, just because it has that fraction in there. So that looks pretty bad right now. Once again, what do you think my u should be? Well, yeah, we're going to use the yuckiest thing. So it is going to be the x to the third plus 3x. And when I find my du over dx, just finding the integral of that, so that's going to be 3x squared plus 3. All right? Now, trying to cover all the bases here, again, this is a little bit tricky. But first of all, in this case, I think I am going to get that dx on the other side. So I have 3x squared plus 3 dx. And you might notice that I can actually factor this. There is a common factor of 3, so I can pull that out. So it's 3 times x squared plus 1 dx. And sure enough, that does look pretty much like what I have in the problem here. Here's an x squared plus 1, and here's a dx. The thing I don't like is that 3 there. But notice what I can do. I can say that this du over 3 is going to be x squared plus 1 dx. All this I think you can figure out is just some kind of algebraic trickery just to get things to match up. So now this is pretty good. I think this is about what I want. I'm going to change colors here a little bit. So notice my original integral now is going to be equal to this integral. So I'm going to have du over 3. Notice that's the same as this x squared plus 1 dx, which is what I have here. And the only other thing I need then is to multiply by 1 over u. This x cubed plus 3x happens to be in the denominator. Well, I know from working with integrals a little bit now, I see this 1/3 that I have here, right here. I can pull that out, and then I'm going to be left with 1 over u du. Almost done, believe it or not. Now, 1 over u, what's the integral of that? Well, I think you should be getting the hang of this by now, that the integral of 1 over u is that natural logarithm. So ln of u, don't forget your plus c, and I'm almost done here now. I substitute back my original u, which was x cubed plus 3x. And ta-da! I am completed. So this is called U substitution. Tough stuff, but we're going to work on this for the next couple days, and you'll be able to do just fine. Thanks for listening, and we'll see you guys in class.